For the continuation of Quarter 1, Module 1, we have the second learning competency, solves quadratic equations by extracting the roots, factoring, completing the square, and quadratic formula. Our objective for this learning competency is that at the end of this lesson, you are expected to solve quadratic equations using the appropriate or the easiest method. Our topic for this second learning competency is solving quadratic equations. We can solve real-life problems in different ways, so as quadratic equations. In solving quadratic equations, we are looking for the right value or values of a variable to make the equation true. These values are called roots or solutions of the given equation. It is very important that you will choose the easiest way to solve a given quadratic equation for you to save time and avoid errors to happen. There are different methods in solving quadratic equations. The first method is extracting the square roots. Second method is factoring. Third method is completing the square. And the last method is by the use of the quadratic formula. So for now, we're going to start with the first method. Let us start with the first method, which is extracting the square roots. So first, let us have a review. Here are different examples of numbers with rational square roots. First, square root of 25. The square root of 25 are positive 5 and negative 5. Next, square root of 144. The square root of 144 are positive 12 and negative 12. And then, square root of 169. The square root of 169 are positive 13 and negative 13. For the next set, we have numbers with irrational square roots. So for number 1, square root of 8. We cannot think of a number that when multiplied to itself, the number is 8. So in here, we will determine factors of 8 wherein one of the factors is a perfect square number. So for 8, the factors are 4 and 2. And 4 is the perfect square number. So the square root of 4 are positive and negative 2. And the other factor, 2, will remain inside the square root. Next, square root of 75. The factors of 75 wherein one of the factors is a perfect square number are 25 and 3. And 25 is the perfect square number. The square root of 25 are positive and negative 5. And then 3 will remain inside the square root. Next, square root of 245. So the factors of 245 wherein one of the factor is a perfect square number are 49 and 5. The square root of 49 are positive and negative 7, and then 5 will remain inside the square root. And then for number 4, square root of 13. So for square root of 13, we cannot think of the factors of 13 wherein one of the factors is a perfect square number. So meaning, for square root of 13, the answer are positive square root of 13 and negative square root of 13. For the last set, numbers with no real square roots. Number 1, square root of negative 2. Number 2, square root of negative 4. Number 3, square root of negative 24. So meaning, there will be no real square roots if you will take the square roots of negative numbers. So the answer for these 3 will be no real square roots. So now, I hope you already recall the different ways on how to determine the square root of a particular number. So let's now proceed with method number 1. So we have solving quadratic equations by extracting square roots. So quadratic equation that can be written in the form x squared equals k can be solved using the method extracting the square roots. So in using this method, apply the following properties. So there are 3 properties. The first property is, if k is greater than 0, meaning that is a positive number, then x squared equals k has two real solutions or roots. So that is by taking the square root of k. Next property, if k is equal to 0, then x squared equals k has one real solution or roots. So that is 0. Number 3, if k is less than 0, meaning that is a negative number, then x squared equals k has no real solutions or roots. So we have here the different illustrative examples. Number 1, x squared minus 4 equals 0. Solution. Given. First step is to add 4 on both sides of the equation. So x squared minus 4 plus 4 equals 0 plus 4. So for the left side, cancel negative 4 plus 4. Then we have x squared. Equal sign. 0 plus 4 is positive 4. So since the value of k is 4, which is a positive number, we will use the first property. If k is greater than 0, then x squared equals k has two real solutions or roots. So meaning, the values of x must be two real solutions. Next step, take the square root of both sides. The square root of x squared is x, then the square root of positive 4 are positive 2 and negative 2. So the values now of x are 2 and negative 2. These are the two solutions of the equation. And that is example number 1. Now, let's have example number 2. X squared equals 0. So for the solution, first we have the given. And since the value of k is 0, so we will follow the second property. If k is equal to 0, then x squared equals k has one real solution or root, and that is x equals 0. Now, let's prove that the value of x is 0. Next step, take the square root of both sides. So the square root of x squared is x. And then the square root of 0 is 0. So 0 is the only solution. And we prove now that x is equal to 0 if k is equal to 0. Next example, number 3, x squared plus 16 equals 0. So solution, write first the given. Second step, add negative 16 on both sides of the equation. So x squared plus 16 minus 16 equals 0 minus 16. So for the left side, so cancel 16 and negative 16. And we have x squared. Equal sign. Then 0 minus 16 is negative 16. Since the value of k is negative 16 or a negative number, so let's have the third property. If k is less than 0 or negative, then x squared equals k has no real solutions or roots. So since we cannot get a number when multiplied to itself to get negative 16, the equation has no real solutions. So for number 3, the answer is no real roots. And for the last example, 4x squared minus 16 equals 0. Solution, we have the given. First step is to add 16 on both sides of the equation. So 4x squared minus 16 plus 16 equals 0 plus 16. So for the left side, negative 16 plus 16 is 0. So cancel the two numbers. Then we have 4x squared. Then for the right side, 0 plus 16 is 16. Next step, divide both sides by 4. So 4x squared divided by 4, so cancel 4 on the numerator and denominator. Then 16 divided by 4 is 4. So we have now x squared equals to 4. The value of k is 4, which is a positive number. So meaning, we will follow the first property. There must be two real solutions for the value of x. So next step, take the square roots of both sides. So the square root of x squared is x. Then the square root of 4 is positive and negative 2. So these are the two solutions of the equation, positive 2 and negative 2. And that is the last example for the first method. So extracting the square root. Remember, we will use extracting the square root if the quadratic equation is in the form x squared equals k. Then follow the three properties as your guide to determine what kind of solution or roots you need to obtain. So again, the first property is, if k is positive number, so there must be two real solutions. If k is 0, then the value of x is 0. If k is a negative number, there will be no real solutions. So with that, let's have the second method. The second method is factoring. So let's have first a review about factoring. So the instruction is, factor each of the following quadratic expression. Number 1, x squared plus x. So you need to determine the common factor between the terms. So the common factors of x squared and x is x. And then divide the given expression by the common factor. So x squared divided by x is x. Then x divided by x is positive 1. And this is the factors of the first expression. Next, number 2, 5x squared minus 25x. The common factor between 5 and negative 25 is 5. Next, the common factor of x squared and x is x. Then divide each term by the common factor. 5x squared divided by 5x is x. Next, negative 25x divided by 5x is negative 5. And the factors now of expression number 2 is 5x times quantity x minus 5. For number 3, the given is x squared minus 16. So since there is no common factors between the two terms, so we will follow this procedure. First, determine the factors of the first term. The factors of x squared are x and x. Next, the factors of the last term. The factors of negative 16 are negative 4 and positive 4. So I hope you remember this kind of example, so which is the product of the sum and difference of two binomials. For number 4, x squared plus 8x plus 15. So first, the factors of the first term. The factors of x squared are x and x. Next, the factors of the last term. The factors of 15 that will give us the sum of 8 are positive 3 and positive 5, because 3 plus 5 is 8. And the factors now of expression number 4 is quantity x plus 3 and quantity x plus 5. Next, for number 5, 2x squared minus 8x plus 6. So the factors of the first term are 2x and x. Next, the factors of the last term are negative 2 and negative 3. So since the coefficient of x squared is greater than 1, so we will follow this procedure in order to determine if we obtain the correct factors. First, the product of the inner terms. Negative 2 times x is negative 2x. Next, the outer terms, 2x times negative 3 is negative 6x. Then combine, negative 2x plus negative 6x is negative 8x. Your answer must be similar to the middle term of the given expression. And since they are similar, so meaning our factors are correct. And these are some of the examples on how to factor quadratic expressions. So for the reminders, you should recall your knowledge in factoring before proceeding to this lesson. If you can do it using your notes from your grade 8 mathematics, you can check it on this YouTube video of Number Bender. So here is the link of the YouTube, and this is the picture of Mr. Number Bender. But if you are ready for this lesson, let us now have the different illustrative examples. Number 1, x squared minus 4x equals 0. Solution. So we have the given in standard form. Next step, we will factor the quadratic expression. The quadratic expression is x squared minus 4x. In order to factor this expression, we will determine the common factor. The common factor between x squared and 4x is x. And then we will divide the quadratic expression by the common factor. X squared minus 4x divided by x, the answer is x minus 4. Then, equals to 0. Next step, apply the zero product property by equating each factor to 0, then solve for x. So we have x equals 0 and x minus 4 equals 0. So for the value of x equals 0 is already the first value of x. And next, for x minus 4 equals 0, we will use the addition property of equality. But to shorten the procedure, we will simply transpose or transfer the term to the other side. Remember to change the sign of the term as you transpose it to the other side. So from negative 4, this will become x equals positive 4. And these are the values of x. So 0 and positive 4. So let us check if the obtained values are correct. So in checking, we will substitute the obtained values to the original equation. The original equation is x squared minus 4x equals 0. So for the first obtained value, we have x equals 0. We will substitute 0 to the variable x. So 0 squared minus 4 times 0 equals 0. So 0 squared is 0. 4 times 0 is 0. Then equals 0. 0 minus 0 is 0. And 0 is equal to 0. And this is correct. For the second obtained value, which is 4, again, substitute 4 to the variable x. So 4 squared minus 4 times 4 equals 0. 4 squared is 16. Negative 4 times 4 is negative 16. Then equals 0. 16 minus 0 is 0. And 0 is equal to 0. And this is also correct. Since upon checking, we arrive at an equal value, so meaning we solve for the correct value of x, so which are 0 and 4. Let us now have example number 2. X squared plus 6x equals negative 5. Solution. From the given, we will transform the equation into standard form. And the standard form of the equation is x squared plus 6x plus 5 equals 0. Next step, factor the quadratic expression. First, the factors of the first term. The factors of x squared are x and x. Next, the factors of the last term. The factors of the last term that will give us a sum of 6 are positive 5 and positive 1, because 5 plus 1 is 6. Next, apply the zero product property by equating each factor to 0. Then solve for the value of x. So we have now x plus 5 equals 0 and x plus 1 equals 0. So for x plus 5 equals 0, we will transpose 5 to the right side. So positive will become negative. So x equals negative 5. Next, for x plus 1 equals 0, so transpose 1 to the right side, and we have now x equals negative 1. And the values of x now are negative 5 and negative 1. Let us now check. So again, substitute the obtained values to the original equation. So the original equation is x squared plus 6x equals negative 5. So the first value is negative 5. So substitute negative 5 to the variable x. So negative 5 squared plus 6 times negative 5 equals negative 5. Negative 5 squared is 25. 6 times negative 5 is negative 30. Then equals negative 5. 25 minus 30 is negative 5. And negative 5 is equal to negative 5. Next, the obtained value is negative 1. Substitute Negative 1 square plus 6 times negative 1 equals negative 5. Negative 1 square is 1. 6 times negative 1 is negative 6. Then equals negative 5. 1 minus 6 is negative 5. So negative 5 is equal to negative 5. So again, this is correct. So since in our checking, we obtain an equal value, so we solve for the correct values of x. So x equals negative 5 and x equals negative 1. And that is example number 2. So now let's proceed with example number 3. 3x squared minus 2x minus 5 equals 0. Solution, we have the given. Next step, factor the quadratic expression. So the quadratic expression is 3x squared minus 2x minus 5. So factoring. So the factors of 3x squared are 3x and x. The factors of negative 5 are negative 5 and positive 1. So since the value of a is greater than 1, so to check whether we obtain the correct factors, we need to multiply the inner terms and the outer terms. So the inner terms are negative 5 and x. So negative 5 times x is negative 5x. Next, the outer terms, 3x times 1 is 3x. Then combine, negative 5x plus 2x is negative 2x, which is similar to our middle term. So this is now the correct factors, 3x minus 5 and x plus 1. Next step, apply the zero product property by equating each factor to 0, then solve for x. So we have 3x minus 5 equals 0 and x plus 1 equals 0. So for 3x minus 5 equals 0, transpose negative 5 to the right side. This will give us 3x equals positive 5. And then, divide both sides by 3. So cancel 3 on the numerator and denominator. So the first value now of x is 5 over 3. Then for x plus 1 equals 0, transpose positive 5 to the right side. Positive will become negative. So the two values now of x are 5 over 3 and negative 1. Let us now check if we obtain the correct values. So substitute the obtained values to the original equation. The original equation is 3x squared minus 2x minus 5 equals 0. The first obtained value is 5 over 3. So substitute. So we have 3 times 5 over 3 squared minus 2 times 5 over 3 minus 5 equals 0. For 5 over 3 squared, the answer is 25 over 9. Then multiply 2 to 5 over 3, the answer is negative 10 over 3. Then we have negative 5 equals 0. Then 3 and 9 could be simplified. So they are both divisible by 3. As we simplify them, we will arrive at 25 over 3. Then copy negative 5 over 3 and negative 5 equals 0. Since the two fractions are similar, so we can subtract the numerator. So 25 minus 10 is 15 then over 3. Then we have negative 5 equals 0. 15 divided by 3 is 5. Then copy negative 5 equals 0. So 5 minus 5 is 0. And 0 is equal to 0. So for the next obtained value, which is negative 1, so again, substitute. So we have 3 times negative 1 squared minus 2 times negative 1 minus 5 equals 0. So negative 1 squared is 1. Then negative 2 times negative 1 is positive 2. Then copy negative 5 equals 0. 3 times 1 is 3. Then 2 minus 5 is negative 3. Then equals 0. And 3 minus 3 is 0. And 0 is equal to 0. So again, we obtain an equal value. So meaning, we arrive at the correct values for x, which are 5 over 3 and negative 1. For the next example, we have 3x squared plus 6x equals 0. So for the solution, So same with example number 1, we will determine the common factor. The common factor between 3x squared plus 6x is 3x. Then we will divide the quadratic expression by the common factor. 3x squared divided by 3x is x. Next, 6x divided by 3x is positive 2. Then equals 0. Next step, we will equate each factors to 0. So we have 3x equals 0 and x plus 2 equals 0. And now let's solve for the value of x. So for 3x equals 0, we will divide both sides by 3. So for the left side, 3x over 3, so we will cancel 3 on the numerator and denominator. And then 0 divided by 3 is 0. So the first value now of x is 0. Next, for x plus 2 equals 0, transpose positive 2 to the right side and positive will become negative. So the two values now for x are x equals 0 and x equals negative 2. Let us now check if the obtained values are correct. So the original equation is 3x squared plus 6x equals 0. The first obtained value is 0. So substitute 3 times 0 squared plus 6 times 0 equals 0. 0 squared is 0. So we have 3 times 0. 6 times 0 is 0. Then copy equals to 0. 3 times 0 is 0. Then plus 0 equals 0. And 0 plus 0 is 0. And 0 is equal to 0. So this is correct. The second obtained value is negative 2. So substitute 3 times negative 2 squared plus 6 times negative 2 equals to 0. So negative 2 squared is 4. So we have now 3 times 4. 6 times negative 2 is negative 12, then equals 0. 3 times 4 is 12, then minus 12 equals 0. So 12 minus 12 is 0. And 0 is equal to 0. So again, we obtain an equal values. So meaning, we solve for the correct values of x, which are 0 and negative 2. And for the last example, the given is x squared plus 8x plus 12 equals 0. So solution. So first, the factors of the first term. The factors of x squared are x and x. Next, the factors of the last term, which is 12, that will give us a sum of 8 are positive 2 and positive 6, because 2 plus 6 is 8. And then equate to 0. So x plus 2 equals 0 and x plus 6 equals to 0. So for x plus 2 equals 0, transpose positive 2 to the right side. So positive will become negative. Next, for x plus 6 equals 0, so positive 6 transpose to the right side. So we have x equals negative 6. And the values now of x are negative 2 and negative 6. Let us now check. The original equation is x squared plus 8x plus 12 equals 0. The first obtained value is negative 2. Substitute negative 2 squared plus 8 times negative 2 plus 12 equals 0. So negative 2 squared is 4. 8 times negative 2 is negative 16. Then copy plus 12 equals to 0. So 4 minus 16 is negative 12. Then copy plus 12 equals to 0. Negative 12 plus 12 is 0, and 0 is equal to 0. Next obtained value, negative 6. So substitute negative 6 squared plus 8 times negative 6 plus 12 equals 0. Negative 6 squared is 36. 8 times negative 6 is negative 48. Then plus 12 equals 0. And 36 minus 48 is negative 12. Then copy plus 12 equals 0. Negative 12 plus 12 is 0, and 0 is equal to 0. So again, we arrive at an equal value, so meaning we solve for the correct values for x. So negative 2 and negative 6. And that is the last example for factoring. So I hope you understand all of the given examples for the first two methods, which are extracting the square roots and factoring. So if you have questions, you may still address your question to your respective mathematics teachers. So now, so for the third method, so kindly watch the next video. So thank you and good luck.